All right, so these are our last properties of logs. It can actually be a really good idea at the end of your notes, maybe, or maybe at the start of your notes somewhere. I would recommend actually taking all of these properties of logs and putting them all together. So you can have all 6 properties, well, 3 properties, but each had 2 parts, all 6 all together for your reference. I think that's going to be very beneficial. But this is the sum and difference properties. If we add 2 logarithms and they have the same base, that's the same thing as 1 logarithm with their insides multiplied by each other. Kind of crazy. We'll see that in action soon. And similarly, if we subtract 2 logarithms with the same base, that's the same thing as 1 logarithm, but we divide their insides. As a quick warning or note, there's no property for this. If you have addition on the outside, we have a sum property. Addition on the inside, there's nothing we can do. Okay. So there's no property for this, and it's certainly not the same thing as this. All right, so watch out for that. So let's do example 10. Write the following with a single logarithm. They all have the same base. So if we add logarithms, that should be just multiplying their insides. Add these 2 logarithms together. That's the same as if we multiply their insides. 5 times 8 is 40. And we're still subtracting this log over here. And now we do it again. Now we're subtracting 2 logarithms with the same base. So we use the difference property. We can just divide their insides. Right? That's what it says over here. Subtract 2 logarithms with the same base, divide their insides. And if we type in any of these things, we'll get the same number. What's log base 3 of 20? I certainly don't know off the top of my head. Is that the same thing as what we started with? Is that the same thing as log base 3 of 4? Plus log, wait, was it actually 4? 5 and 8 and 2. Oh. Log base 3 of 8 minus log base 3 of 2. By golly, gee whiz, look, they are the same. Okay, so this property, it works, at least in this case. And remember, if you want the full rationale for where this comes from, you can find it online or in our textbook. Or you can talk to me about it. I'll show you too. But I don't, this section's already long enough. I don't want to add more stuff if I don't have to. So how can we evaluate this log without a calculator? Whoa, that seems tricky. Well, let's try to rewrite it. Maybe there's some magic, because if we can't rewrite it, we can't do this without a calculator. So if we rewrite it, what can we do? We can't add these logs together just yet, because this first log has something in front of it. We got to deal with this part first before we can combine the logs together. So this first one, remember we can use the exponent property. This becomes log of 5 squared. And remember, this is the common log, log base 10. You don't see a base of the logarithm, it's base 10. And now we can simplify this first one. 5 squared is 25. Okay, still not seeing how this is going to help us yet, but let's just keep going and try to combine these and maybe something will happen. Now we have 2 logs that are just by themselves added together. We can use that addition property. Right, the log of one thing with a base, as long as the log doesn't have anything else going on, plus the log of another thing with the same base, just multiply their insides. We multiply their insides, 25 times 4. Ah, this is nice. Why is this nice? Because this is log base 10. So we can rewrite this again as 10 raised to some exponent. Because if we can write 100 as 10 raised to some exponent, then we get cancellation. So it's 10 to the first power is 10. 10 to the second power is 100. Great. 10 to the second power. We can use a third property. Oh man, we're using almost every property in this problem to simplify. The logarithm cancels the exponential. We're just left with that 2. That was a first property from the very first video from this section. And again, if you typed it in, 2 log 5 plus log of 4. Ah, look, that's 2. Beautiful. Do one more problem and then go on to the final section. Rewrite this logarithm as a sum or difference of logs. So split this up as much as we can. Here we combined them. In example 12, let's split it up. Again, just work on our muscles, just getting some practice. Not going to look any better or worse. Might look a little worse. We're just practicing how to use these properties. We have 2 numbers divided by each other on the inside of a logarithm. 2 numbers divided by each other is the top logarithm minus the logarithm of the bottom. So this is going to be the logarithm of the top minus the logarithm of the bottom. Now we're going to keep going. Notice we have a logarithm of 2 things multiplied by each other. We can't actually bring the 4 down yet because the y doesn't have a 4. We can only bring the exponent out in front if everything has the same exponent. So we have to split up the x and the y first. If I have a log of 2 things multiplied by each other, that's going to be that addition property. That's the logarithm of the first plus the logarithm of the second. And again, we still have the minus ln of 7 at the end. Now there's one more property that we can do. Technically, we've done everything it asked us to do already. But if we really wanted to use as many properties as we could, again, this is an okay answer, then that 4 is going to come out in front with that exponent property of logs. And we'll get a very expanded version. Again, sometimes compressed versions are good. Sometimes expanded versions are good. That's it. Let me know if you have questions. We'll get into some solving in the next one.